Hello, welcome to Block 2, Use of Algebraic Notation, Lesson 4. I'll share my screen. So, in your previous lesson, you learned how to use letters to generalize number operations. So, those were the building foundation of understanding just how algebra works. And in the lesson before that one, you worked using single function machines, but you were using only numbers. In this lesson, you'll be using those same concepts of function machines, but this time we'll be using letters. Okay. To be specific, you'll be using terms and expressions, and you're going to see what they actually mean in this lesson. But before we start, I would like you to do the retrieval practice. You can pause the video and do the retrieval practice. You can do it for 3 minutes. Okay, make sure you pause the video to do the retrieval practice. This helps you recall what you learned, and it also gets you ready for the lesson. Okay, let's go through the answers. I'm sure you've paused and you've worked through the retrieval practice. Okay, so if you recall from our previous lesson, you can write this in any order. Okay, remember that word commutative. So we could have written this as 4 times y. So you have 4y. This one, remember, when you multiply two letters, similar letters, you can write it as y with a little 2. So we can say this is y squared or 4y to the power 2. And then that's the same for 1b. And then for 1D, you remember when we multiply two numbers, we multiply the numbers and then we write the letter next to the result of the multiplication of those numbers. So our answer should be 16y. And then if you remember from our previous lesson using the bar model, you know that for our bar model, and I'll repeat, it's important, you add in each of the blocks. So if we add each of the blocks, you see that 2 plus 2 plus 2 will give you 8, and then you add in r to it. Okay? So we cannot say 8r because that won't be right. We say 8 plus r. So it's important you understand that because we're going to see more of that in this lesson. Okay, let's learn some new concepts. Remember, the title of our lesson is you using function machines, but this time you're using letters with single function machines. Okay, and then for those letters, the specific terms, the specific words you hear me use are terms and expressions. So consider this function machine. Consider this machine here, this function. We're multiplying by 2. So if we put a term, so this is a term, okay? 6b is a term. When we put in a term, we can actually represent this as a bar. We say, okay, we have 6b, which is just one bar. But if we're multiplying by 2, it means we're doubling. We're doubling the bar. Now, remember, we add the bars, okay? So we can write this as 6b. Okay, we can write this as 6b plus 6b, which is 12b. Another way to think about it is to say this is simply 6b, double of 6b is 12b, because we can rewrite this as 6 times b times 2. Okay? All right, and that will still give us 12b. Because if you remember, we can multiply the numbers, and then we can simply write the letter next to it. Okay, so it's really important that you get this concept. All right. Okay, so but what about if we have 6b? So for the term, the algebraic term, 6b divided by 2, again, it's the same thing. If we want to represent it as a bar model, we can say, okay, we have a bar that is 6b, but we need to split it into 2 equal parts. Now, if we split the bar into 2 equal parts, it means we're going to have 3b. Okay? Yeah? Because another way of thinking about it, you can say, okay, let's even check whether we're right. Yeah? Because to check, remember the bars, we add them. So if this is 3b, and then that's 3b, so you remember we add the bars. Yeah? So if we add the bars, this will be 6. This will be 6b. So halving them gives us 3b. Okay, what about if we're asked to add 2? Now, if we think about it using the bar model, we have a single bar of 6b, but we need to add another bar that is 2, because that's what it means. Remember, for the bar model, we'll add the bars. Okay, so this will simply be 6b plus 2. Okay. Okay, what about if we have 8x subtract 8? I want you to think, is there a mistake by saying, yeah, imagine you have a friend, and if you show the friend this and they say, oh, I think the answer will be 8x, because you just take away the 8. Now, remember, thinking about the bar model, 8x means 8 lots of x. All right, 8 lots of x. So if you have 8 lots of x, and then you want to just take the number 8 from it, we're not going to get an actual answer. Don't you think so? Because it will look like this, right? But you want to take 8 from this. Does it really make sense? You want to take a number from a letter. Remember what we said, the letter is a variable. We don't know what it is. Okay? So it makes sense to just say, oh, okay, it's just 8x minus 8. Okay? That's just what we write. Okay? So we don't know the value of what the x actually is, but we know we want to take 8 from it. So we just write 8x minus 8. Okay? Okay. I want you to pause the video and answer question 1 and 2 for 4 minutes. So pause it for 4 minutes, answer the questions, and then when you're done, you can play the video again so that you can mark your work. Okay. I'm going to presume you have paused the video, you have really thought about this work, and you have answered the questions. So let's check the answers. All right, look at these. So here we have G times 4. Okay, so remember, we're working with function machines, but this time we're putting letters. So the term G times 4 will simply be 4G. So if you remember, we always write the number before the letter. Then this one is C plus 4. C add 4. Okay. Remember, if these were two separate bars, if we represent it as a bar model, we'll just write C plus 4. Then this one will be G plus 4. All right. And then this one you have 3n, and then you have times 4. Okay, you multiply them by 4. So you can simply, if you remember, you can simply write this as 3 times 4 times n. Okay, so the numbers will multiply each other and you simply write the letter next to it. Okay, and then this one, you can just write 4c. So you write the number next to the letter. And then this one, you can, if you add in the bars, you can simply just write 3n add 4. Okay, look at question 2. Again, they're just blocks. Yeah, so 2 blocks, you split the 2 blocks in one box into 2 separate boxes. You just have one box. Then 4u divided by 2 will give you 2u. 2a. Okay, so those are the other answers. I'm sure you got them right. If you didn't get them right, you can go back to our very first lesson to our previous lesson in algebra, and then check again to make sure you understand the basics, because once you get the basics right, then you should be able to understand this. Okay, let's look at this one. What if we start putting expressions? Okay, so when you have something like this, we call it an expression. Okay, remember when we were just putting single terms, 6b, letter A, letter B, we call those terms. So if we put an expression, what happens? So imagine again, if we think about this as a bar model, this will be a bar that is 4x and another bar that is 10. Remember, for the bars, we're simply adding them. Now we're dividing by 2. So what if we can split each bar? Okay, we'll now have 2x and each of the other bars will be 5. Now we can rearrange it to show what actually happens, because now we have this bar which has been split into 2 and the other one which has been split into 2. So if we rearrange it to show what actually happens by splitting these, we're going to get 2x add 5. So the result of 4x plus 10 divided by 2 is actually 2x plus 5. So you can think about it as a bar model, or you can just think about it with what we say abstract, the way we've been doing it from even our previous lesson. You know that dividing by 2 will divide the 4x and then we'll divide the 10. So our answer will be 2x at 10. At 5. 2x at 5. What about this one? If you remember from our previous lesson, when we were working with function machines, just using numbers, how do we get the input? I want you to pause and have a think. How did we get the input when we know the function, what the machine is doing to whatever we put in, and the output? So we have those two, but we don't know what was put in. Okay, I'm sure you remember we do the inverse operation. We do the inverse operation. So the inverse, remember the inverse of adding 6 is to subtract 6. So it means we need to do 12w plus 9 minus 6. 12w plus 9 minus 6. So if we do that, you would see this happens, so that we'll know exactly what was put in. So if we do 12w plus 9 minus 6, okay, remember If we were to represent this as a bar, this will be 12W bar. This will be the 9 bar, but we want to take away 6. It only makes sense that we can only take 6 away from the 9 bar. We can't do that from the 12 W's. We don't know what the W's are. It's not an actual number. We don't know what it is. So actually, if we can take 6 only from this, your answer will now be 12W plus 3. So that is what was put into the machine. Okay? Really important for you to think about what's going on here. Okay? All right, let's move on. Okay, I would like you to have a go at the rest of the questions. So remember, before you start working, what we've learned so far. So far, we have learned that you can use inverse operations to find out the expressions or the terms that were put into the machine. We also learned that you can perform operations, so either add, divide, subtract, or multiply on expressions. You can do the same thing that you were doing to numbers, but remember you have to stick to the rule of algebra which we learned from our previous lesson. Okay, so I'd like you to pause the video and answer question 3 and 4. You should be able to do this in 3 minutes. Okay, assuming you've paused the video and you've worked through these questions, here are the answers. Okay, so they're asking you explain the mistake and find the correct output. So here, the person was adding instead of actually multiplying. So the correct output should actually be 6b. So if you remember, 2b, you can multiply the number with the number and then you write the letter next to it. And then here, okay, you cannot add this because these are two separate bars. Okay, so remember in the bar model, we have, if we rewrite this is 3 lots of A plus a bar that has 4. So we can, our correct output will be 3 add 4. Then this one will be just 5y minus 5. Okay. Then this one will be 2a plus 1. Okay, if you remember from our previous example. Then this is the answer for question 4. Okay, we can simply just write these as f minus 7, 4h minus 4. Okay, r plus 6. So if you remember, you can take the 1 from the 7 bar, not from the r bar. If you're thinking about it in terms of bar model, we don't know what r is. Here, you can take the 6 from the 8 bar, not from the 6r bar. So we can simply write this as 6r plus 2 because the result of taking 6 from the 8 bar will be 2. So it's 6r plus 2. Okay, here is question 5. You can pause it. You should be able to do this in 2 minutes. Okay, assuming you've paused it and you've worked through it, you've really taken your time to think through your solution, here are the answers. Okay, here you can clearly see when you look at the arrows pointing, you say, okay, that's become 20. That's 20b. And then here, that has become 4 times b, and then this is become 8. So we're clearly multiplying by 4. Okay? So we're clearly multiplying by 4, and then this will be our results. And then this one, we're adding 6. So your expressions or your terms will be these. Okay? So you can either think about it in an abstract manner using what we learned, or you can think about it as using the bar model. Okay? So the last one for C, you can see we're dividing by 2. And remember the way we write, for example, this one, 15a divided by 2, we write 15a, we put a line, and then we put 2. So this is written as 15a over 2, or 15a divided by 2. And then this one we're dividing by 2, so we divide each of the terms of this expression. Okay. I would like you to pause the video and have a go at questions 6 and 7. You should be able to do this in 4 minutes. Okay. Assuming you've paused the video and you've done this, you've really thought about what you're doing, here are the answers. Okay. This one, you times in by 3. You divide in by, here you're adding 3. So the bar of 3, so if you do the inverse operation, you'll find out the input. Yeah. So because you're timesing by 3, you need to divide by 3. Yeah. And then here, if you do the inverse operation, you're taking away 3. Okay. Here, you're dividing by 3. So you need to times by 3. You do the inverse operation. Okay. And then here, looking at B is at the bottom. So B, we need to divide by 3. So these are the inverse operations. Okay, we're going that way. Doing the inverse operation going to the left. Then let's look at C. We're dividing by 4. We're subtracting 4. Okay. So you remember, you can only take away 4 from the 12 bar, not from the 12C bar. So that would be 12C add 8, because when you take away 4 from the 12 bar, you're left with 8. Then here you have to multiply. The inverse operation of dividing is to multiply by 4 to get what you put in. And then here, the inverse operation of timesing by 5 is to divide by 5. So if you divide 10D by 5, you get 2D. If you divide 15 by 5, you get 3. Okay. All right. Here is the answer to question 7. So we can have different function machines. Okay. They're asking how many different function machine will give this output. 4G plus 4. Okay. There are different function machines. Let's just, here is another one. You could have 4G plus 2. Then you can times 2. Okay. Because 2 times 4G is 8G. And then 2 times 2 is 4. So you can have different functions. You can draw different functions to get the same result. So this is our own function that we did just now. And this is another one. Okay. All right. So that brings us to the end of our lesson. So what have we learned so far? So we have learned in this lesson that we can use algebraic terms and algebraic expressions on single function machines to get an output. And we follow the same rules and the same principles of algebra. We can also find the input by doing the inverse operation, which we learned in our previous lesson, to get the input, which would either be a term or an expression. Okay. Until next time,